Okay, good day to all of you. So, I warmly welcome all of you to my channel. So, today we are going to discuss how to do a two-way ANOVA. Not just doing a two-way ANOVA, I decided that I need to introduce what kind of instances we can use two-way ANOVAs in. And also, I am going to help you understand how to transfer data to a software of your choice. Now, here, of course, I'm going to consider Jamovi for this analysis. But if you do use SPSS, the method is going to be basically more or less the same. And then after that, I'm also going to focus on doing the analysis, and then I will help you to do more about learn more about how to go ahead and interpret your findings and also how to develop your research report. Of course, a two-way ANOVA is required when you have a factorial design. Now, without further ado, let me introduce you to my study. Now, of course, this is a made-up study. I wanted to come up with the factorial arrangement or a factorial design to help my second year, second semester students learn more about how to do a factorial how to analyze data that belongs to a factorial design. Now, let's take a moment to go through the title that we have here. The title is English Proficiency, Self-Efficacy and GPA of Sri Lankan Students Studying in the United States. It's a very specific title. We are focusing on a very specific population here. Those are Sri Lankan students who are currently studying in the United States. And we are going to learn about three different aspects of them. That is the English proficiency, self-efficacy, and their academic performance that is operationalized through GPA. Now, let's take a moment to read through the introduction here so that we could understand further what this study is going to be all about. Most international students who attend undergraduate and postgraduate programs must take English proficiency test. Now, you know that we do IELTS, TOEFL, PTE. Any student who is going to go for a foreign country where they speak English as the first language, you are required to take a exam, right? So that is something that all of us know. Now, English proficiency is generally considered as an indicator of student success because it is not the sole predictor. Maybe this change from one major to another as well. But at least in the field that I was in, at least in the area that I studied, proficiency in language is very important. If not, it's very difficult to understand these abstract concepts. So, some universities do offer scholarships for the students if they can achieve beyond a specific level of CEFR. For example, IELTS 7 and above in undergraduate is sometimes rewarded by like $1,000 scholarship per year, something like that. In the university that I studied, that was the case. So, although there are multiple aspects to university success, in this study we focus only about GPA, and also we are going to see how the proficiency of language and also one's own self-beliefs of efficacy is going to have an impact on this overall performance. So GPA is used to understand the overall performance, academic success of the student, and we are saying here that one's English proficiency and beliefs of efficacy have something to do with this. So this is the basic study. Here, language proficiency was measured using IELTS, and students are divided into three groups based on their proficiency. Now, division was was done using common European framework of reference levels. In this study, we have considered three levels, B1, B2, and C1. B1 and B2, I think they roughly translate to, I think B1 should be about 5.5. I'm not too sure, you can check on that. And C1 is generally, I think, about 7.58, something like that. So students were also divided into two groups based on their efficacy scores as well, high efficacy, low efficacy. And then through a degree audit report system, you can get the GPA of students as well. Now, this is not a real study. This is a hypothetical study that I just developed to show like how exactly one should go ahead and do a study like this. But I think at undergraduate level, something like this is an excellent study. Not just undergraduate, depending on how you would justify it and how what kind of other protocols you have thought about. Maybe it's good for a master degree, research as well. But let's forget about those things. But let's just focus on how this study can be analyzed and how exactly we are going to go ahead and do it. Now, title, I think the title is all right as of now. Of course, you can change it in any ways that you would like. Maybe you can kind of show the way in which this relationship would work and can have like the independence position first, and then you can clearly mention that they might have a impact on the dependent variable in your title. Those are okay. But in when you design this, I want you to actually focus on the overall number of groups that you need to have in your study. Now, this is one of those areas a lot of students get confused. When you want to do a factorial arrangement, you need to first realize each independent variable has number of groups. Now, here in this case, English proficiency based on IELTS score, we have divided students into three groups: B1, B2, and C1. So that independent variable has three levels. And then based on their self-efficacy score, we have divided again those individuals into two as uh, high efficacy and low efficacy. So in this case, what happens is the second independent also has two levels. So this is a 3 by 2 factorial design. 3 by 2 has come, the number of numerals here in this would indicate how many independents you have. And if you get the first number, if it is 3, what it means is the first independent has 3 levels. The second independent actually has 2 levels. So 3 by 2 means 3 into 2 is 6. Altogether, we are talking about 6 groups. We are going to see how the dependent variable, that is, the GPA, we are going to see how the GPA varies across these 6 groups. Now, one thing that I do always is I keep the title with me and then I actually create this table. This table will help you to understand more about what exactly you are going to do in your study. In a method section, it would be a very good decision if you can show this table under the design section. I usually ask my students to categorize the method section into 6 components as the design, the sample, the tools, procedure, analysis, and ethics. So in the design, when you explain your independence and the dependence, how you have designed your study, how the factorial arrangement works can be demonstrated something like this. So here I have English proficiency. This is one of my independent variables, and I have my 3 levels B1, B2, and C1. This is my self-efficacy. That is another independent variable, that is low efficacy and high efficacy. So technically, 3 by 2 means 6 groups. The 6 groups are, I am going to check the GPA of students who have B1 proficiency and low efficacy, B2 proficiency and low efficacy, C1 proficiency and low efficacy, B1 proficiency and high efficacy, B2 and B2 and high efficacy, and C1 and high efficacy. So technically, based on my theory, I am thinking the highest GPA would come in this particular tab or this particular group where they have the highest proficiency and the highest efficacy. And I hope the lowest would come from here. I don't know as of yet because I don't have the data, but I think that is exactly how it should go. Because low efficacy means you don't believe in yourself and you don't have provisions, so then it might work like that. Now, what I need right now is I need to have my hypothesis. Now, in a two-way ANOVA, there are interaction effects, main effects, and also simple effects. Now, when you develop hypothesis, usually what I personally do is I develop hypothesis for my main effects and I also develop a hypothesis for my interaction effect as well. Some actually researchers, they display the interaction effect first and then go for the main effects as well. But you can go through a research paper where they outline what exactly the process that you need to go through. But generally speaking, yes, if you can list down this hypothesis. But here in this two-way ANOVA, the main concern anyway is to go ahead and check for the interaction, because theoretically there needs to be a reason for you to go for a factorial arrangement like this. If it theoretically doesn't make any sense, then there is no reason for you to go for a factorial design or a factorial arrangement. So then uh, interaction is what I'm really interested here in finding, but then I have listed main effects as well. Why? Because if my interaction is not working, then I need to have a few other hypotheses that I can show that I have demonstrated here. So I have three hypotheses here. The first one, remember now I am listing here only the alternative ones. English proficiency has a statistically significant effect on GPA. Now, if you just want to find this, just this, then it's a matter of comparing these three groups for their GPA. So then this would be something that you can do with a one-way ANOVA. No issue. This is my next hypothesis. Self-efficacy has a statistically significant effect on GPA. Then that would be just comparing these two for their GPA. That would be a t-test. Now, those are my first two hypotheses. But here, I don't need to run a one-way ANOVA and a t-test and all of that. Why? Because I'm going to run a two-way ANOVA. An ANOVA with two independents uses a two-way ANOVA. So here, my interaction effect is evaluated through the hypothesis. English proficiency and self-efficacy have a statistically significant effect on GPA. So I am going to see whether this entire group comparison is going to make sense. I am going to see whether there are noticeable differences across all of these groups in this particular study. Now, this is exactly what I want to do. Now for this, I have designed, now I have developed my hypothesis. I will just bold these hypotheses so that you can take better note. Now, these hypotheses are required when you want to run a two-way ANOVA. I hope it makes sense how exactly I formed the three hypotheses for my study. And if you notice, all these three hypotheses have derived from this, and this design connects well with the title that I have as well. So always keep the title next to you when you do something like this. Okay, that's a very important thing, and no compromise at all in that. Now, I need to come up with the sample size. Now, I have recorded another video for this particular sample size calculation through G-Power, so I'm not going to get into this. Now, since you have an understanding about how this designing works, let's go through the dataset that we have. This is our dataset. Now, if you notice, once again, this is a hypothetical or made-up data. I made this up. The first column is for the the numbers. I have 36 individuals here. This is the degree that they have chosen. Here I have 10 degrees. I have first listed all the 10 degrees here, and the rest I would have to again, re-enter based on uh, how I have identified each one of these. So when you transfer your data, you have to make sure that you properly number them. And here I have, erroneously entered 6 point, that need to be 3.8. Now, the next one is the CEFR value. Here I have B1, B2, and all of that. So these are all written in text. And here I have given GPA. Now, if you are to transfer this data properly, here's what you can do. You can actually do this in Excel and transfer the data. If not, you can directly transfer this to Jamovi and do it like that as well. No issues. So here's what I'm going to do. I'm going to just go for a paste special and just copy and paste the text. Now I don't actually need this number. So I'm going to just remove it. I don't need it. Now I told that CS is up to CS2 chemistry. These are 10 different degree programs. You can either substitute these manually if you know how to enter this with what you call different Excel formulas and all of that. That is also all right. But I'm just going to go with a bit of a manual method. I am going to, replace these ones. I'm going to select this replace option. I'm going to say CS, replace it with 1. Okay, now we did the replacing. and then management information science, yeah, management uh, MIS, not MSI, MIS, but that's okay. I'm going to replace that with 2. Okay, like this. And then BBA is going to be 3. Okay, replace. Psychology is going to be 4, like this. And then chemistry is going to be 5, like this. I'm going to replace that as well. The main reason is I don't want to make this super complicated by adding formulas and all of that. I know it will take a little bit of time, but then again, you can still get the analysis done. That's what matters, right? Nursing is 6, pre-med, pre-med is 7, education is 8, accounting is 9, robotics is 10. Okay, we have just very quickly replaced all our uh, text under the first variable. Now I'm going to copy this and paste this in Jamovi. Open Jamovi and then just paste it like this. See, all 36 data is now pasted. Now click on this column header, double click, and then I'm going to name my variable, that is major. This is a nominal variable and I'm going to represent everything by the integer. So I'm going to minimize this. Now I need to name my levels. I think even if you don't name this, the analysis will run, but it would be far more easier if you can identify each label here. So one, we discussed this was computer science. So I'm going to add this. See, it automatically changed it. And then 2 is actually MIS, Management Information Systems. Here I have done a small mistake. So I'm going to write it as MIS. Third, that is BBA, Business Administration, Bachelor of Business Administration. And then fourth one is psychology, like this. So this is not a fast video. If you want, I think you can play this at 1.5x speed so that you can have a faster experience. I wanted the students who actually are very new to statistical analysis to do this with me, so they can have this video on a separate device and do it with me. So that's the reason why I did it like this. So fifth one is chemistry, and then 6 is nursing, 7 is pre-med, 8 is 8 is education, 9 is accounting, and 10, okay, the final one, robotics. Okay, done. Now we just finished entering all the data. See, now all the data is added and they are labeled. Good work. Now I need to go for my second one, that is CEFR. If I open my Excel, I do have that as well. I think I can just go ahead and let me copy this to Jamovi. Let's see whether we can get all of this properly copied and pasted. Let's open Jamovi. This is our second variable. I'm going to pay. See, now when you put it here, it automatically change it to text instead of integer. Now, the analysis might probably not run if that's the case, but anyways, that's okay. I'm going to just label these. Sorry, one is B1, like this. 2 is B2, like this, and then 3 is C1. Now let's see whether when I change this, whether it will go or not. I think probably it might go. Yeah, see it went. But that's okay. I'm going to again copy and paste. I think when I copy and paste again, it will all appear. See, now it appears very well because I already had defined them. Now it recognizes B1 is 1, B2 is 2, and C1 is 1. So we don't have to worry about this. I'm going to write it here. English proficiency. Now, I used to use SPSS some time back, but I think for psychology students, even if you don't do very high-end analysis, we can always use R for high-end analysis. But if you don't have that kind of thing, so you need to have a cleaner set of results, I think Jamovi is a very good option. I'm going to do the same for my third variable as well, that is self-efficacy. Let's copy and paste this to Jamovi. Paste it here. Now I'm going to write. Now here, low efficacy has to be named 1 and high efficacy has to be named 2. If you swap this, in case if you need to run a correlation, the results might get slightly weird. So I'm going to do that. I'm going to write 1 is LS, low self-efficacy. 2 stands for higher efficacy. And now I'm going to change this to integer. Probably it will go away. I'm going to copy and paste my data again. Okay, now it appears very well. But I need to change this. Higher efficacy has to be 2, low self-efficacy has to be 1. Let's see whether I can actually change it. Okay, no, I can't change it. I need to remove this. And I'm going to replace this from here and then copy and paste. LS should be replaced with 1. HS should be replaced with 2, like this. Okay. Now I am going to copy and paste all of this to Jamovi, like this. And I'm going to tell now, first one is low self-efficacy, LSE. 2 is HSE, high self-efficacy. Okay, now this is all done. And I'm going to write here self-efficacy. That is also done. Last one is CCA GPA, that is a continuous variable. So that is all right. I just need to go ahead and copy it in a different one. Here, I'm going to name it as GPA. It's continuous. Okay, that's all right. No levels over there. Okay, now all the data is actually added. See, now we have a very clean set of data. And here I'm not going to change it because it is already recognized as with integers. So I'm not going to include the name here. So that's okay. It's already recognized. So that's fine. We'll keep it like this. Okay, now let's go ahead and do our analysis. So I don't need this Excel file now. So I'm going to just maybe don't save and just close it. Now let's go for a basic descriptive analysis. Now I need to go ahead and check the overall GPA of the individuals that I have. So take the GPA and put it under variables. I click on the exploration option and went to descriptives. You can do the same in SPSS as well by analyze descriptives and explore. Here in the statistics, I am going to select the most important ones. N is 36, that is given here. I don't need the missing value, so I'm going to remove it. So declick this and it will go away. I need mean, I don't need median. And then standard deviation is here. The minimum GPA here we have the total data set is 2.40 and the maximum is 3.98. So if you want, you can copy this data and paste it directly to your Word so that you will get this in a very clean way because this is already APA format. You don't need to format it again. So maybe you might need to change the font and font size and the line spacing, but that's it. You don't need to create a table again. That's a very cool option. And you don't need to get Shapiro-Wilk here, because if you want, you can later check for normality based on different independent variables. So that is something that you can do. But I would encourage you to further refer how to get normality for two-way ANOVA. If I get for the total distribution, I think the total distribution is pretty normally distributed, no issues. If we go for Shapiro-Wilk, Shapiro-Wilk is also fine, no issues for the overall distribution. But in case if you want to go for the distribution based on each levels or groups in the independent variable as well, that is something that you can go ahead and do. But what is exactly required for a two-way ANOVA, that is something that you need to go ahead and read. Usually it is said that these tests are robust for minor violations. So I'm just going to go with that. Once again, remember, my objective today here is not to justify on that, but to show you how to do a two-way ANOVA. Okay. Now, more descriptive analysis, I'm going to take self-efficacy for the splitting variable. If I do that, I can get all of this for self-efficacy as well. And I'm going to, click here, variables across rows. See, now this would be very clean. Here also you can actually get Shapiro-Wilk for this. Now, see, it's not necessarily violating normality. Even for GPA, based on GPA, if you categorize based on self, if you categorize GPA, still I think the data looks pretty okay. We have 18 individuals for lower self-efficacy, 18 for higher efficacy. And if you notice the mean difference, the mean GPA for low efficacy and higher efficacy is just about 0.21 points, 3.02 and 3.23. So descriptively, you can see there's a slight difference of efficacy. You can see the efficacy has a bit of an impact in causing some changes in the GPA, but sometimes this is not enough to show statistical significance. Usually, bigger differences do get statistically significant. If the difference is smaller, you need to have a bigger sample size to detect these statistical significance here. But the minimum GPA here is 2.50. But if you notice higher self-efficacy, the minimum is 2.40. Maximum here is 3.43. Here 3.98. Okay, that's fine. I'm going to get English proficiency here as well. Now, you can actually do further exploration. Now, I'm going to just keep this guy here. If you do this by English proficiency, B1, B2, and C1, you can see the means show a very noticeable increment, mean GPA. B1 has 2.86 GPA, B2 has 3.08, and C1 has 3.44. From 2.8 to 3, maybe not too much of an increment, but definitely from 2.86 to 3.44, that's a noticeable increment. And minimum and maximum GPAs also show a noticeable difference here. In terms of Shapiro-Wilk, I think one variable, one level violates the normality assumption in the distribution. If you need, you can forget about Shapiro-Wilk and go for skewness and kurtosis. If you click on those, maybe skewness, okay, no, here I think these values are a bit extreme. So yeah, maybe I think it's actually violating. So that's okay. So we know it violates now. See, that is exactly what you need to do. You can either descriptively discuss how the data, whether it is normally distributed or not. You can get probability plots for that as well. If not, you can simply run a Shapiro-Wilk test, or in SPSS you have Kolmogorov and Smirnov test as well. But the usage of Kolmogorov, Smirnov, and Shapiro-Wilk, there's a difference. One is sensitive to the sample size, the other one is not so. So it would be better if you can read and justify which method you are going to use when you do it. But since the intention of this one is for second year students, that kind of justification is not necessarily needed right now. So because I am mostly interested in research methodology and how to apply this and how to understand about data, and not necessarily statistics. So a statistician may have a very different approach here. Okay, now that's the English proficiency. I'm going to get that out as well. You can actually do the study by major. If you get now, I think for some we don't have adequate data. That's why this doesn't generate. But if you remove this Shapiro Wilk, we don't need that. Let's if you just focused on the standard deviation, because this is just one individual, one MIS, one accounting and robotics, so of course you can't generate a standard deviation for that. But if you notice, computer science, the GPA is 3, psychology 3.29, and then here we have again 3.23, 3.23 chemistry. So I think psychology and chemistry have the highest GPA. So these are all good descriptive analysis. You need to do a good amount of descriptive analysis before you go ahead and start reporting your data. And this is for the overall overall group of 36 individuals. GPA is 3.13. That's for the overall group. So if psychology is one is 3.23 or 3.29, what it means is psychology students generally tend to have an average GPA that is slightly above the overall average of the total sample. Now I am going to do this as well. You can actually include English proficiency and self-efficacy. All the 6 groups that we discussed are here. B1, low self-efficacy, B1, high self-efficacy, B2. This is the 2 by 3 design that we were talking about earlier. So B1, low self-efficacy, should have the lowest GPA. And yes, they do have the lowest GPA, 2.75. And then B1, higher self-efficacy, there's a bit of an increment. B2, low self-efficacy, bit of an increment. B2, higher self-efficacy, there's an increment as well. So like we decided earlier, the highest GPA comes from C1 proficiency and higher efficacy, that is 3.63. There's the minimum and maximum values as well. And if you want, you can run Shapiro-Wilks for each one of these distributions as well. I think apart from everything else is well distributed, no issues. So maybe we can actually go ahead and run a two-way ANOVA for this, no issues. Now, here's what I'm going to do. Now, I need to run an ANOVA. I'm going to click on this ANOVA option, and I'm going to click on this ANOVA here. Now, this will ask you for the dependent variable. Dependent variable is my GPA. What are my fixed factors, English proficiency, and self-efficacy. Now this is my initial ANOVA table. English proficiency. Yes, English proficiency has a statistically significant effect on the GPA. Let's check which hypothesis is that. English proficiency has a statistically significant effect on GPA. So this hypothesis can be accepted. Self-efficacy also seem to have a significant effect on GPA. I can accept that as well. Yes, no issues. But however, when you get the interaction, English proficiency and self-efficacy, now this is not statistically significant. This is 0.163. It is not less than 0.05. So this is not accepted. So I have failed to support my third hypothesis to accept it. So I can't, I don't have data to display an interaction effect. As a result, I have to reject this third hypothesis, but I can accept my first one and the second one. So there are 2 main effects. Okay. One independent to the dependent, that relation, that's the main effect. But the 2 together with the dependent, that interaction, I don't have it. I can click on the model fit overall model test. If I go with the overall model is also the two-way ANOVA, the overall model is, yes, that is statistically significant. But I have 2 main effects, but my interaction is effect is not statistically significant. And I can get the effect sizes for this as well. eta squared. I can click on that. This is given here, eta squared. So if you look at this, English proficiency, it has 0.508, self-efficacy 0.101. So seems like English proficiency is the one that has the highest impact depending on these effect sizes as well. Okay, so there's partial eta squared as well, and then we have another effect size here. Okay, but I'm going to just select eta squared. That is more than enough for me. Okay, that's enough. And then if we click on the model, okay, that is given here, assumption checks, I can go for the homogeneity test. Homogeneity is also fine. It is 0.136, so it is not violating homogeneity assumption. So I think, yeah, we can actually go ahead with the two-way ANOVA, no issues. And then post hoc tests, I need to do a post hoc test for, you can, if you need, you can just take for English proficiency. English proficiency, these are the differences. You can select two keys or keys. Then if you need to have any, what do you call, corrections for the post hoc analysis, now I'm going to go with this. Two keys test. According to what we have done here, B1 and B2 shows a noticeable or statistically significant difference. Yes, we can actually get the effect sizes as well through Cohen's D. See, these are very big Cohen D values. These are highly significant. The differences are very noticeable. And B1 and C1, that is also statistically significant. B2 and C1, that is also statistically significant. And if you need, you can get another table for self-efficacy as well. Between self-efficacy high and low, yes, once again, if you run a t-test, once again, that is also statistically significant, and the Cohen's D indicates there's a noticeable difference as well. And if I put both of these, because we were interested in a 2x3 design, here, if we do this, you can see out of the 6 groups, which ones are statistically significant. Now, you have to read it like this. Those who have B1 proficiency, low self-efficacy, compared with B2 low self-efficacy, once again, not significant. So I'll rather go with the ones that are significant. This one is significant. That would be B1 low self-efficacy versus C1 higher self-efficacy. Now that is significantly different with each other. And again, this one, B1 higher self-efficacy versus C1 higher self-efficacy. That is statistically significant. And again, this one here as well. And you have a few others as well. This one is also significant. This one is significant. So I think what you have to do is you have to copy and paste this in a Word document or in Excel. And then after that, you can maybe color the ones that are less than 0.05, and then you can come to a understanding as to which groups are statistically significant in their differences. Those who have B1 low self-efficacy compared with C1 higher self-efficacy, and then this is just to see which groups are statistically different in their differences. So you might have to very slowly analyze this to understand which groups are different from one another, because we don't have interaction effect here, but still there are groups that are different from one another, different pairwise comparisons. So here they have run total of, I think you can calculate how many, 1 2 3 4 5 6 7, yeah, it has done multiple group wise pairwise comparisons. So just the way that you do this is B1 LSC with B1 HSC. B1 LSC with B2 LSC. Likewise, you have to go ahead and see whether they are statistically significant or not. So it takes a bit of a process. It's a painstaking process. This is exactly why we need to have a bit of practice with what we do, and you have to do this slowly as well. So you have to spend some time doing this so that it will make sense to us how exactly we need to go ahead and compare our data. Now, this is what you need to do: run descriptives, and then check for the assumptions, run the ANOVA, and then finally run the post-hoc test. Now, SPSS might not sometimes give the comparisons for a two-way ANOVA. I ran it with some of my students and we couldn't get, but Jamovi actually provides a good comparison between all the groups. But interpretation of this would take a little bit of time. Now, that is exactly what you would have to practice. So I hope now you have an understanding about what to do in a two-way ANOVA. Now, let's see how exactly we are going to interpret this in our results section. Now, this is a sample results section I wrote. The data is slightly different from the Jamovi to here, what I have done here. So, but the basic understanding would be pretty much the same. It would be a wise decision for you to have your Grammarly also installed so that you can correct grammar mistakes on the go itself. So here I have started with descriptive analysis to understand the nature of the data obtained. First, a series of descriptive analysis were conducted. A total of 36 undergraduate students took part in this study. This is the total GPA the GPA divided GPA calculations for the total variable. The sample had an average GPA of 3.21. The highest GPAs were among psychology students and chemistry students. Now we got 3.2 and 3.29 as our GPAs. I think the issue was when I first ran this data set, I mistakenly had included one of the GPAs as 6.28 or something, 6.38. Sorry, 6.98. So I changed it to 3.98 because you can't have GPS more than 4. I think that's one of the reasons why our means were slightly different. But that's okay, just forget about that. But this would be the basic reporting style. The lowest GPA was noted among MIA students, that is 2.6. So table 2 has the average GPAs, MIS. So these are the GPAs. We can demonstrate that as well. And table 3, average GPA of participants by level of efficacy. You can do some analysis like this. Here it says higher efficacy, you have 3.40, low efficacy, you have 3.02. Now you don't need to keep this number 1, number 2. You can actually remove it when you have to format this a little bit, because this is directly Jamovi output and I decided to put the number here previous time, that's why. But if not, you don't need here. Even in this table, you can just remove these ones. You don't need to have this. So good formatting is always required. Like this, you can remove it. Okay, so we have very clean tables. That is exactly what we need. Similarly, it was noted that students with higher efficacy will have noticeably higher GPAs as opposed to low efficacy students. We have done that comparison. A similar trend was noted in GPA based on English proficiency as well. Compared to B1 students, GPA was significantly higher among C1 students. That is available in table 4. You can indicate that this result is in table 4. What is important is don't just give blank tables. In between tables, you need to have some amount of you need to have some amount of narration. Narration is very important. Now here, once again, you don't need to have these numbers. I'm going to remove them. But you can very clearly see how exactly the GPA changes from one level to another. And then we have standard deviation values given here as well. So think of this as a story that you are telling. You have to very clearly mention what exactly you have found. Followed by this descriptive analysis, assumptions were tested to conduct two-way ANOVA to test hypothesis. Plural, hypothesis. As per the results given in table 5 and table 6, multiple distributions violate assumptions of normality. Now, this is a different data set. I think, like I told, there were some differences. So based on this, there are minor issues. And here I have given some more information about, once again, the distribution for English proficiency, distribution for self-efficacy, and so on. But in our Jamovi analysis, we actually ran an analysis for each comparison as well for the distributions. And then we ran homogeneity of variance similar to normality. Homogeneity of variance is also violated. So this is the formatting technique for homogeneity of variances when you check for the Levene's test. You can watch my video on one-way ANOVAs as well, where I further explain how exactly you need to go ahead and report this. So overall, the present study does not meet parametric assumptions to undergo a two-way ANOVA. However, the non-parametric equivalent Kruskal-Wallis test does not accommodate factorial design for analysis. As a result, the researchers had to proceed with the parametric ANOVAs for testing hypotheses. Now, as per the inferential statistics that we did, the overall model is significant. Self-efficacy and English proficiency do not have an interaction effect, but the overall model is significant. So here, I haven't given the overall model, but I have said that self-efficacy and English proficiency do not have an interaction effect, so that I have given here. And you can see the effect size is also very low. Similarly, self-efficacy also shares no significant relationship with GPA. Now, this is based on a different data set. However, English proficiency does have a significant effect that I have given here. This significance confirms the existence of a main effect, although the interaction effect was not significant, thus H1 is accepted. Now, in the Jamovi analysis we run, our findings were slightly different. Here, English proficiency and self-efficacy, both of these are statistically significant. But in the previous study that I ran with a slightly different data set, it was not significant. So here I have mentioned H1 is accepted, H2 and H3 were rejected. And here we did the post-hoc comparison as well. This post-hoc comparison is slightly different to what we did here. But then again, the basic comparison style would be the same. Higher self-efficacy B1 and higher self-efficacy C1, those two are statistically significant in their differences. Higher self-efficacy B2 and higher self-efficacy C1, significantly different. Higher self-efficacy C1 and low self-efficacy B1, the differences are significant. Higher self-efficacy C3 and low self-efficacy B2, statistically significant, the differences. Now, this is exactly how you would do the comparison, but when you compare, you have to write your comparisons in the format of t-tests like this. As per the pairwise comparisons performed via Takis HSD, GPA significantly differs among B1 and C1 in the higher efficacy groups, and then you give the report, your findings according to the reporting standards of a t-test, and you can do the same for the rest as well. But this is the basic idea. This is how you would run a two-way ANOVA. Now you can see there's quite a lot to actually analyze in a two-way ANOVA. So when you design your study, if you can maybe reduce it to a 2x2 design instead of a 3x2, your analysis would be even further easier. So each time you need to go for an analysis, you need to make sure you have a credible reason to go for a set of independent variables. Why, for example, why do you need two independents instead of a one? There needs to be a theoretical justification for that as well. And also you need to think about how much of group comparisons you would have. So please consider these things when you go for a two-way ANOVA. So I hope I was able to give you some understanding about how to do a two-way ANOVA, how to enter the data, how to analyze it. So you can use this understanding to do your coursework and maybe do your other research projects and all of that. So thank you very much, and feel free to check out other videos that I have uploaded as well. And if you have any questions, you can post your answers as a comment. So thank you very much.